anybody has any doubts, I'll be happy to answer those.
Yes, sir. Question 17, sir.
Question 17, okay. Question 17, type A is here. Let me take question number 17 on the PPT. Any other questions so that I can take the questions in one go, guys? Other than questions,
sir, example number 13.
हर एग्जाम्पल क्वेश्चन में जरूर आ गया होगा बेटा. एनीवे क्या एग्जाम्पल में क्या प्रॉब्लम है? आई डोंट हैव द बुक ऑनेस्टली.
सर उसमें लेंथ नहीं दिया है सर.
So you share you put only the question on the group then. Just take the photo of the question and just put the question on the group, that's all.
Okay sir.
Okay, don't do anything else, only the question you can put. Any other question than 17 and the one he's talking about the example, guys? Any more questions and where you may be having doubt? I can take them in one go and then we can discuss them out.
So question number 13, sir.
13.
Question
okay,
number 16.
Sorry,
I'm not able to. 16, sir. Final draft. I'm not able. 16.
Final drafts you're not able to calculate. Okay, I'll ask you why you're not able to calculate better. Duplicate. So I'll take this one here, 17. It's one doubt. Okay. 16th is another doubt. Okay. That's the PDF. 16th. 13th you said or 16th? 13th you said, right?
13, sir.
13, okay.
13 and 13, sir. दोनों बोले थे.
Okay, then after taking 16th, I'm closing the PDF. I hope there are no more doubts from this section. And I'll take from WhatsApp the question on from the example, whatever somebody is having a problem with that. Okay. This is 16. This is 13. Have you put the example also on the group, beta?
Yes, sir. I just put it down.
Okay, I'll just take it that also. Stability. Okay. Here is the example that you're talking about. So all the 4 doubts are with us on this. I'll just take you quickly through them one by one so that then we are in a position to start the next topic. Okay. Okay, guys, let me just share the screen with you. I've taken the questions. And the screen is already shared, so let me just put on my tab also. Screen is shared. I must have my headphone also on. Okay, let's start with. Here is the 17th question. A ship arrived at the port 7 meters and 10 meters. Please confirm audio visual is clear. Kindly confirm.
Yes, sir.
Yes, sir. Okay.
Yes, sir.
7 meters and 10 meters. Center of flotation midships, MCTC, TPC. Maximum permissible drafts to cross the bar at the dock entrance is 9 meters. Due to damaged forepeak, the forward draft is not to exceed 7 meters. So forward final draft has to be 7 meters. Find the amount of cargo to discharge into barges from these 2 spaces so that both conditions are satisfied. What are both conditions? You should be able to cross the bar and you should be basically just not losing on any cargo. So you should be basically loading to the maximum possible level so that you can safely cross the bar. So I know what the doubts somebody may have. once I make the line diagram, you will be comfortable. AF will be half the length, whatever the length is. It's not given here, L by 2. Okay, never mind. Never mind, it's okay. So forward draft is 7 meters. Half draft is 10 meters. When you cannot have the forward draft exceeding 7 meters, so you have to maintain it 7. And aft draft, you have to cross the bar at 9 meters. That means you have to bring the aft draft to 9 meters. Correct, Peter? Yes or no?
Yes,
Am I
sir.
right?
Yes. Yes, sir.
Okay. So now basically you have the initial drafts, forward aft, final drafts, forward and aft. So what you can find out is initial height draft. And when you do the initial height draft, L will get cancelled out. It will be mean of these two. It will be 17, 8.5 meters will be the initial mean height draft. Why? Because center of flotation is midships, right, Beta? Am I right? Who had the doubt? Initial height draft will be 8.5, yes or no, Beta? It is mean of 7 and 10, correct? Final height draft will be mean of 7 and 9, that is 16, 8 meters. Okay. Find the minimum cargo to discharge. So mean rise that you expect is 0.5 meters, which is 50 centimeters, into the TPC of 25, 0, 25, so many tons is the total cargo to discharge, right? Who had the doubt? Have you understood better, or have I gone too fast for you to understand? Tell me.
ये तो समझ आ गया, sir.
Yeah, so now you'll be able to split it into two spaces. You have a space 30 meters forward of here, and you have a space 50 meters off. So now it has become like the other question that we had done.
Yes,
So it
sir.
is W tons here, it is 1250 minus W. We had done a question like this, yes or no, beta?
Yes, sir. Sir,
You
ये
know
वैसे
the
हो जाएगा ना, trimming moment final is equal to.
Initial trimming moment will be equal to, no, sorry, final trimming moment will be equal to initial trimming moment plus minus the trimming moment cost, right?
Yes, yes, yes.
Now it's clear? Una?
Yes, sir. हाँ जी, हो गया, sir, समझ आ रहा है.
Okay, fine. We go to 13 then. Okay, anybody has any doubts? Sorry, I skipped too fast. Anybody has any doubts? You'll be able to do the 17th one now?
Yes, sir.
सर ये फाइनल हाइट ऑफ 8 मीटर कैसे आया सर ये?
आप बताओ कैसे है, आप निकालो, कैलकुलेट करो.
ओके, इनिशियल तो सर हम सर जैसे अगर इनिशियल हम करेक्शन तो आप ड्राफ्ट लगा के भी निकालेंगे सर, तब भी इतना ही आएगा ना सर?
8.5 निकालो ना मेरे भाई, निकाल के देखो ना.
ओके सर.
इतनी देर तुमने पूछा, इतनी देर में तुम निकाल लेते बेटा. तुम
नहीं सर, मैं एक्चुअली शेप से सर बहुत बारिश हुई, मैं अभी जस्ट पहुंचा ही सर घर पे, अब पूरा रोड जाम
कैलकुलेट उठा और निकाल.
ओके सर.
अच्छा, बारिश हो रही है शेप में आजकल?
जी सर, पूरा जाम हो गया, वहाँ पूरा भर गया था सर.
अरे सेंटर ऑफ फ्लोटेशन इज मिडशिप ड्राफ्ट इज आल्सो मीन ड्राफ्ट, सो हाइट ड्राफ्ट विल बी सेम एज मीन ड्राफ्ट. हां,
लेंथ दिया नहीं तो इसलिए वो निकाल.
अरे क्या फर्क पड़ता है, ऊपर में भी लेंथ आएगा. अरे मेरे भाई,
नहीं सर, वो आई नो कि वो एचएफ सेम है तो आ जाएगा. आप बोल रहे थे
1 second. Half draft minus the correction. Initial trim is 3 meters into AF. AF is L by 2 upon length, which is L. L and L gets cancelled. It becomes 10 minus 1.5, which is equal to 8.5. What is the issue? By your formula, you're getting 8.5, yes or no?
Yes.
L and L gets cancelled out, na bachche? Half draft minus correction will also give you 8.5, yes or no? Am I
Yes,
right?
sir. Yes, sir. Yes, sir.
Right sir.
Yeah, you can calculate also. So if you want to just stick to what you learned earlier, then also it will give you 8.5. Likewise, the final draft will be 9 meters aft, 9 meters aft minus correction. Final trim is 2 meters. So 2 meters into L by 2 divided by L, L gets cancelled, 1 equal to 8 meters. Final draft, the high draft is 8 meters. Correct, Peter? Yes or no?
Okay sir, understood sir, understood.
Yeah, so it will, by calculation also it will give you the same answer, don't worry. Question number 13, guys. A ship 160 meter long, MCTC so much, TPC so much, HF 3 meters aft, draft so much, forward and aft. from where W tons may be discharged such that the draft aft remains constant. Okay, fantastic. Let's say forward, let's make the line diagram. And guys, if anybody is not understanding, you can unmute and interject anytime, please. H, 3 meters aft. Length 160 to 80 minus 377. From where should W tons be discharged so that the aft draft remains constant? So forward draft is 6.8. And he doesn't want the aft forward draft, so that's all. Aft draft is 7.8. He wants it to remain constant. Now tell me guys, and he's talking of discharging. So tell me, when you discharge, look at the aft draft, which was initially 7.8. When you discharge something from the ship, will it cause rise or sinkage?
Rise.
So if I apply rise to 7.8 aft, will the draft become more than 7.8 or less than 7.8?
Less than
7.8.
Okay, but you don't want it to be less than 7.8. You want it 7.8. That means now something should take it back to 7.8. What is the other correction applicable aft? One is the rise or sinkage, which is rise in this case, TA of the trim cost, right? So, yeah, TA has to be equal to your rise. Otherwise, you can make a equation in the aft draft. Final draft aft is 780 equal to initial draft aft 780 minus mean rise. So now what you have to do here is you have to figure out where should you discharge from. So should TA be, so here you have to little bit think. Should TA be plus or TA be minus in this case? Tell me.
Plus.
See, I have 7.8 minus mean rise plus minus TA. I have only two options, either to add or subtract, should be equal to 7.8. So if mean rise is minus, then TA should be plus, correct?
Plus.
For TA to be plus, what should be the name of the trim cost?
By stern.
For TA to be plus, the name of the trim cost should be by stern. What is causing the trim? You are talking to yourself. What is causing the trim? Discharge of W tons. So where should I discharge so that the trim is caused by stern, guys? With respect to center of flotation, should I discharge from forward or
forward?
So let us say I discharge. So this part you'll have to reason out, and let us say I'm discharging X meters forward of center of flotation. So now, you see, 7.8 gets cancelled. This implies mean rise and TA are equal. What is mean rise going to be equal to? Mean rise will be equal to W upon TPC. TPC is 30. What is TA equal to be? It is going to be equal to TC into AF upon length of 160. Look at the line diagram. What will be TC equal to now? TC will be equal to W into X upon MCTC of 200. Guys, what I'm circling here is TC into 77 upon 160. W gets cancelled and you'll get the value of X. Correct, beta? Am I right? Yes or no?
Yes, sir.
And your answer will be the weight should be discharged from so many meters forward of center of flotation. So you have to give whether it has to be discharged from forward of center of flotation that many meters or aft. So your answer has to be, it has to be discharged so many meters forward of center of flotation. Is question number 13 clear to everybody now?
Yes.
सर ये समझ नहीं आया परसों माइनस प्लस वाला
आप आपके पास क्या चीज है, किसमें इक्वेशन बना सकते हो? लुक एट द लाइन डायग्राम.
वही कल वाला जो ड्राफ्ट फाइनल इज इक्वल टू द
तो उसी में बनाओ, कोई बात नहीं, यू विल कम ऑटोमेटिकली कम. नो वरीज, यू मेक इन दैट. Initial draft aft is 780, final draft aft is 780. You make the equation then. What will it be equal to? 780. Final draft aft will be equal to initial draft aft 780 minus mean rise You all told me plus TA. So what will happen now? 780 कैंसिल हो जाएगा. इसको सिंप्लीफाई करोगे तो क्या करेगा? मीन राइज इज इक्वल टू TA. यस और नो बेटा?
सर माइनस क्यों होगा सर मीन राइज सर? बिकॉज
मीन राइज क्या होता है?
सर वॉट एवर
ड्राफ्ट बढ़ेगा घटेगा?
इसमें ड्राफ्ट तो बढ़ेगा, मतलब समझिए डिस्चार्जिंग ऊपर ही आएगा शायद सर.
तो उससे ड्राफ्ट बढ़ता है या घटता है?
सर कम होगा सर.
तो फिर कम के लिए माइनस करते हैं प्लस करते हैं?
ठीक है सर, ठीक है, ठीक है सर, ठीक है, ठीक है.
कौन सी दुनिया में चला गया इंदर सडनली? वेयर हैव यू गॉन? You know why these doubts are coming? क्योंकि कल प्रैक्टिस नहीं की. ठीक है? तो your quality of question will tell me. Anyway, की तो बहुत अच्छी बात है, पर की नहीं है, कोई बात नहीं. Don't worry. Is it okay, guys? 13th question is okay now? Let me take the 16th one. Length 160, MCTC, HF 2.8 meters forward, TPC given, present drafts are given, 720 tons cargo is to be loaded, space is available in 2, how much to put? If the arc draft required on completion is 7 meters, what is the, so it will be an equation in the after draft, guys. You know the initial draft after and forward draft after. What is the issue? 16th, what is the problem you're facing? Who had the doubt in 16th?
सर मेरा ही डाउट था सर, फाइनल ड्राफ्ट
क्या डाउट था? क्या डाउट था?
सर जो इक्वेशन बनाया, फाइनल ड्राफ्ट इज इक्वल टू द इनिशियल ड्राफ्ट. तो मेरा सर ये समझ नहीं आ रहा है, जो ट्रिम कॉस्ट माइनस प्लस कहाँ से करेंगे सर ये वाला इनिशियल ट्रिम में अपने पास?
अरे भाई, यू आर मेकिंग इन द फाइनल ड्राफ्ट ना, तो व्हाट इज द इशू? क्वेश्चन में डाउट क्या है तेरी? मुझे समझ नहीं आया क्या लिखा है तूने. फाइनल ड्राफ्ट आप?
यस सर.
बिकॉज मैं भी बिना लाइन डायग्राम करूंगा फिर मैं कंफ्यूज हो जाऊंगा. तो 7.4 फाइनल ड्राफ्ट इज रिक्वायर्ड. Aft is 8.8. Final draft is 9 meters, is it? Yes,
Yes,
9 meters. Center of flotation, no, sorry, H, my mistake, sorry, H. Center of flotation is 2.8 meters forward, so F is here, 2.8. Length is 160, so 82.8 meters is AF. Then you have the space available in number 2 lower hold, so somewhere here you want to load. This distance is 45 minus 2.8, so that will be 45, 42, 42.2 meters. And you have 35 meters off somewhere here. This distance will be 35 plus 2.8, 37.8 meters. Total to be loaded is 720 tons. So let us say W tons is put here. So 720 minus W is put here. Now, what is the issue? Tell me, Inder. Did you make a line diagram like this?
Yes, sir.
Where did you get stuck now? Tell me. Did you get W or no?
सर W आ गया था सर, मैं वो मेरी
W मैच कर गया
सर, वो गलती पता लगी, 42.8 ले लिया था मैंने सर, हो गया सर.
ओके, ठीक है, डन. ओके, फाइन. Now this example, a ship, don't worry about these things will just unnecessarily confuse you. Don't learn anything like this. Learn it with basic fundamentals. A ship has to load 600 tons of cargo. Drafts forward are after so much. This is the question we have just discussed. Yes or no? What is the issue?
Yes, sir. But इसमें at the end to find the draft, sir, I got the weights.
Okay. Let me make the line diagram. Drafts forward are 8.5 and aft is 9.7. HF is COF is COF, which is midship. So center of flotation is midship. So AF is half the length. Length is given. A ship is not given, so L by 2. Never mind. Okay, space is available 60 meters forward. So 60 meters forward to load. Distribute if ship is so loading. Okay, so 60 meters forward. And you have another space 40 meters aft. 40 meters aft, you have another space. Space is available, so much okay. and TP. How much cargo to distribute this? How to distribute 600? So this is W and 600 minus W. If the cargo ship is to finish loading on 0.5 meters by stern, so you make an equation in trimming moment, beta. You know the initial trim is 120 centimeters. So final trimming moment will be 50 centimeters. So is the trim. So taking trimming moment by stern as positive and by head as negative. Final trimming moment will be plus 50 into MCTC. If anybody is not understanding, let me know. Will be equal to initial trimming moment is plus 120 centimeters in the trim into 250 plus minus the trimming moment caused. W turns is going to cause by head, so minus 60 W plus 600 minus W into 40, and this will give you the value of W. Correct, Peter? Am I right?
Yes, sir.
How much did you get, Peter? Abhishek, how much did you
Sir,
get? W?
Sir, I got 185 tons. Sir.
So 185 tons, 185 point, how much goes in the forward compartment?
Sorry, 415 goes forward and 185 goes out.
185. And this is matching with the solution?
Yes, sir.
Okay, fantastic. Now your problem is get drafts, right?
Right.
Correct, Beta? Okay, now with this, what can you do? Simply what you have to do is there are two ways of handling this question. Okay. One is you can find the initial hydrostatic draft minus the rise. So there are two ways of doing this question, whichever way you feel comfortable. One is calculate the initial height draft, which will be equal to final initial draft R minus the correction. Correction is 1.2 meters is the trim, and it will be 2 by 2. It will be mean of the two. Okay. So 0.6, it will be 9.1 meter, 9.10 meters will be the initial height draft. Am I right, Peter? Correct? Calculate and see. Because it's midship now, it will be mean of the two. Correct, Peter? Yes, sir.
Yes, sir.
Abhishek, did you get that initial height draft is 9.1? Right? And what did I tell you yesterday? What did I tell you? Height draft is only affected by change in displacement and density. Change of density is not involved. There is a loading of 600 tons that will cause mean rise. Mean rise will be equal to 600 tons upon TPC of, how much is the TPC? 20. So it is 30 centimeters. So 0.300 meters is the mean rise. So final height draft, I don't know how the book has done it. This is one way you can do it. It will be 8.800 meters. Do you agree the final height draft will be 8.800 meters?
Right, sir.
Correct? Okay. What is the final trim? Final trim is 50.5 meters by stern. You can split 0.5 into TATF since it's midship. It will be 0.25 meters here and 0.25 meters here. It will be equal, right? So your final drafts will be forward and aft. Your final height draft is 8.800, 8.800. TATF, and ask yourself of what? TATF of the final trim. TATF of the final trim is 0.250. Since the final trim is by stern, TA will be added, TF will be subtracted, and this is one way you can get the final drafts. Okay, guys? 9.050, and this will be obviously 0.575 and 8.550. Am I right, Better? These will be the drafts. Abhishek?
Right, so, but it's not matching in the question.
It has to match. Unless we just see if we have made any mistake. That's all you have to see. That's all.
Okay. Okay.
There cannot be. Okay. Let me calculate it the other way also. And if it does not match, then we'll see. Sinkers, there will be sinkers, right, sir? We have taken rise. Okay, we have taken rise. Okay, that's what I'm saying. We must have made a mistake somewhere. Okay. Okay, sinkage. So plus 0.5. So this will become 9.300 and this will become 9.300. No, sorry. 1 meter additional. So it will be plus 0.3, right? So it will be 9.4, right? Yeah, so Abhishek, it will be 9.400, 9.400. In the aft, it will be plus 2.50. Forward, it will be minus 2.50. Now you'll get the answers, okay? So if they're not matching, we must have missed out something better.
Yes, sir. Yes, sir. Now it's matching.
9.150
Yes,
and
sir.
9.650, okay?
Yes, sir. Yes, sir. That is what
Okay.
we didn't take.
Since I'm on
Understood.
the subject, let me do the other method also for the sake of people understanding it. Because when I use it in dry docking and grounding, now we know the initial draft forward, we know the initial draft aft. We, by using this W, we can find out the trim cost. Now we know the trim cost. Actually, when you have the final trim, okay, you don't have to calculate initial fine change in trim. You can write like this. Initial trim is how much? 1.2 meters by stern. Final trim is how much? 0.5 meters by stern. So TC is 0.7 meters by head. Is that clear to everybody? Change in trim is 0.7 meters by head, right, guys?
Yes, sir.
Okay.
Right, sir.
You can split this into TA, TF, and since it's midships, it will be 0.350. It will be 0.350 TA, TF, right? And mean rise is mean sinkage is 0.3. Now we can get the drafts forward, aft. What are the initial drafts? Initial drafts are 8.500, 9.700. Mean sinkage plus 0.300 plus 0.300. TATF. Now here you have to again ask yourself, what? This is TATF of the trim cost. And TATF of the trim cost is 0.350. 0.350. Since the trim cost is by head, so TF will be added, TA will be subtracted, and I'm not totaling it, I'm just writing. If I'm wrong, you can tell me, we can check it again. The final drafts, you should get the same answer, 9.650. Are you getting same?
Yes, sir. Yes, it's the same.
Yes, sir.
So whichever way it suits you, both are correct. But TATF, in one case we used of the final trim, in the second case we used TATF of the trim cost. See the difference. We are calling it TATF, but you have to ask yourself and make sure that TATF is used of the correct trim, whether it is of the initial trim, is it of the final trim, or is it of the trim cost. Is that clear, beta? Which method has been used in the book, Abhishek? Is it the blue one or the red one?
So the second one, the blue one.
So that will give you the same answer, whichever way you want to do.
Yes, sir. Yes. Yes. Thank you, sir.
सर ड्राइडॉकिंग में कौन सा वाला मेथड काम आएगा सर?
अबे आएगा जब देख लेना ना.
नहीं सर वही
you'll only remember what will be used in Drydocking. Rest you don't want to remember, right?
No, I want to remember both the sir, but at least ki it will be.
If I've explained both, I expect you to remember both. I don't give options like this. Okay? फिर फायदा क्या हुआ यार इतनी मेहनत करने का अगर तुमने ऐसे सीखना है तो. If you to learn like this, tell me.
सर वो पिछले क्वेश्चन में मेरे को बस आपसे ये पूछना है सर, जो हम इक्वेशन बनाएंगे वो ड्राफ्ट वाली बनेगी ना सर? ड्राफ्ट
everything is now wiped out. It's all clear. You can see all the screens have been cleared off. पिछले क्वेश्चन में you are still stuck with the previous question. Another question has been discussed. Hunar, stay with the class.
Yes sir, वो हो गया था सर, दोनों हो गए थे.
मुझे नहीं पता हो गया था नहीं हो गया था. You know your situation best, बेटा. I don't have to basically. Okay, guys, let's go to our new topic. And the topic, I'll try and do it in 4 sessions starting today. Now, before I start dry docking, I would take you through some things that you know, but we need to use them in the questions, and that is what we should know very clearly. Now, first thing is the concept of GM. When we say GM, we mean initial metacentric height. By default, we mean it's GM fluid. And we all know how do we calculate GM. We first get Km from the hydrostatic particulars. From here, we subtract Kg. What we get, we know we call it as GM solid. From here, we subtract FSC and we get GM fluid. I'm sure all of you know up to this place, correct, guys? Anybody has any questions? Any questions up to this point, Beta?
No, sir, no question.
Oh, yeah, so and how do you calculate FSC, guys? FSC is equal to FSM upon displacement, right? And that goes here. That is one part you need to recall. Second, when you discharge weights, let us say we have a ship like this. Let us say ship has a weight here. Let's say ship has a weight W here, whose kg is, let us say, kg1. And now the ship's full displacement is capital W, and the center of gravity of the ship is here. Now, if the weight is discharged, which side will the center of gravity of the ship shift? Tell me, guys. If this weight is discharged, small w is discharged, which side will the center of gravity of the ship move?
Away from the discharge weight.
Upwards. So you join these. You join these two lines, and it will move in the opposite direction somewhere here. Here, I'm not interested in how much starboard or port it has gone. Since I'm talking of GM, in GM, what will affect is how much has it gone up. So we are only interested in this component of the shift. And this component in pre-C, you know, was called as GG1 vertical, downwards or upwards as the case arose. And when weight W was discharged, what was the formula you found about how much it shifted? This is that GG1. In this case, it is upwards. In some other case, it could be downwards also. And we know from pre-C, it was D vertical upon, in this case, since we have discharged, generally it is W final displacement. But in our case, since it was discharged, it is W minus W. I'm sure all of you can remember this formula now from previous learning. Anybody has any doubts? Guys, tell me if any doubt is there. I'll be happy to answer it now.
सर वेट निकालेंगे तो जी ऊपर जाएगा सर.
Yes, in this case ऊपर जाएगा.
ठीक है.
ऊपर लगा तो है बेटा एरो, ये देखो, ये ऊपर की तरफ तो है एरो, correct?
ठीक है सर.
Right? But in some case it can come down also, depending on. Okay, now most important thing in this case is what is this small d? Anybody who would like to tell me what is this small d in this expression?
The difference between the cases.
Distance from the center of floaters.
Difference.
That's Danny, is it? Arey, Baba, what is this small d? See, that is why I'm discussing it. Otherwise, again, we'll go in spin. What is small d? Small d in this case, it's the vertical distance. It's the vertical distance between the kg of the ship before operation. Before operation, where was the center of gravity? At G. And center of kg of weight W. It is the vertical distance between them. Danny, can you remember it now?
Yes, sir. Yes, sir.
Okay. So please don't make these mistakes. So in this particular case, Here was the center of gravity of the weight. Here was the center of gravity of the ship before discharging. D will be this distance. Correct, bete? Am I right? So it will be basically what? Kg of the ship before discharging minus the kg of the weight involved. Correct, beta? That is your D here. Am I right? Correct,
Yes, sir.
guys?
सर समझ नहीं आया सर
क्या नहीं समझ में आया बताओ?
सर ये kg minus small kg g तो समझ आ गया. G is the distance between the center of gravity of the weight where
So in the
weight-
diagram, how will you get the value of D? Tell me. How will you get the value of D in the diagram? In the
W in
how will you get the value of small d in the diagram? If this is small d, then how will you get it?
सर ऊपर वाले g से नीचे माइनस कर देगा.
तो ऊपर वाले g का डिस्टेंस कहाँ से होगा तुम्हारे पास? Where will the distance of the capital G be given from? Which reference?
Keel sir.
In the
ये थोड़े बेसिक इसमें गोल है सर. नहीं समझ आया सर.
बेसिक गोल नहीं है, धरती गोल है.
सर सच में सर ये सबसे गंदा टॉपिक समझ नहीं आता सर. जी कहाँ जाता है मतलब ये दिस इज वेरी कंफ्यूजिंग सर.
अभी तो तुमने कहा जी किधर जाता है वो तो समझ में आ गया.
हाँ जी समझ आ गया सर. ये वाला थोड़ा समझ नहीं.
What is this distance called? कैपिटल जी का डिस्टेंस यहाँ से इसको क्या बोलते हैं?
सर केजी सर.
kg. ओके.
फ्रॉम कील टू ग्रेविटी.
ये डिस्टेंस को क्या बोलते हैं इस डायग्राम में? मैंने मार्क भी किया हुआ है पहले. It is small kg, the kg of the weight, correct?
Yes sir, small kg. Yes,
So
exactly.
इस डायग्राम में देखो what will be d equal to?
सर that will be बड़ा kg minus small kg. ठीक है सर.
तो मैंने क्या लिखा है यहाँ पे?
ठीक है सर. ठीक.
Is that okay, guys? Okay. Now my question to you is, suppose I'm giving you a hypothetical question. It's not practical. It's not possible, but just a hypothetical question. Here was the ship. Here was its displacement with weight was W. And with this W, she had the center of gravity here. So this was her, obviously the kg. I'm writing for Inder now. And I'm saying theoretically, okay, so don't say how is it possible. I'm just saying theoretically. Suppose this ship had some weight, small w, whose center of gravity was at the keel. So here it was small kg. Now kg, small kg has become 0. And w weight has the center of gravity here. So don't say when will it happen. I'm just saying imagine it happens. Okay. Now guys, if this w is discharged from keel, please mute yourself, Peter. If this small w is discharged from keel, I'm sure all of you will agree that the shift of g will be upwards. So the g will shift vertically upwards. And using this formula, what will this formula now become, Peter? It will be small w in the small w into.
So small w into d, sir.
Why? What is the value of d in this case now, in this diagram that I made?
kg, capital.
Kg, sir.
It is capital Kg. Why? Because the kg of the ship was kg. Kg of the weight discharge is 0, so it will become kg, right? In the
yes, yes, sir, yes, sir.
Divided by w minus w. So it will become w into kg upon w minus w. Am I right, guys? And g will move upwards. Correct, beta?
Yes, sir. Right.
Correct. So, guys,
Yes,
remember, if a weight is theoretically discharged from keel, theoretically, then it will shift the kg of the ship upwards to a distance w into kg of the ship before the operation divided by w minus w, and we have used this GG1 formula. We have not done anything, correct? Am I right?
Yes.
Correct, guys? Remember it. Don't forget. Okay. Now, tell me, secondly, yesterday we did the trim formula. Let us say we have this ship forward end. This is the aft, and it can be either side, doesn't matter. Let's say here is the center of flotation. This distance we all know is AF or LCF. Now, suppose if I discharge some weight from here. Suppose I discharge some weight from here, let us say P tons. Will it cause a change in trim, yes or no?
Yes, sir.
Will it cause a
Yes,
change in
sir.
trim? How much will be the cause in change in trim? We have done the formula yesterday. That's why we were doing it. Look at that line diagram and answer. What will be the change in trim?
P
Speak
into
up.
LCF.
P into
Divided by-
LCF, okay,
LCF.
multiplied by, okay,
Yeah.
LCF, then
Divided by MCT.
divide by MCTC. Does everybody agree? This is P multiplied by liver AF divided by MCTC will be the trim cost. Does everybody agree with it?
Yes, sir.
Right? This is also directly a fallout of what we discussed yesterday. Okay. Abhi dekho, if we don't discuss those things, then again, 1,000 people, you'll have 1,000 doubts as to why it's happening like this. We know that the liver will be from center of flotation, and if it is from after perpendicular, liver is AF, so trimming moment will be P into AF upon MCTC, and this change in trim will be by head, obviously, because you're discharging from stern. Right, beta? Am I right? Discharging from aft. Correct?
Yes.
Does everybody agree? Any questions on these things? Okay. Now, guys, tell me one thing. If my kg becomes more in this formula here, will the GM reduce or GM increase? Look at the thing here.
GM will reduce.
GM will reduce.
GM will reduce, sir.
Very good. So there are three things which I have discussed with you here. One, if something is assumed to be discharged right from keel, then it will cause the center of gravity of the ship to move upwards, and the vertical component of the ship, GG1 upwards, will be equal to W into kg upon W minus W. So when this G moves up because of this discharge in this formula, will the GM increase or decrease if the G has moved up as we see G going up? Will the GM decrease or increase?
GM decrease.
Very good.
GM decreases.
Second thing I have discussed with you is from this line diagram that if P tons of weight is discharged from after perpendicular, then it will cause a change in trim, and change in trim will be by head, and the quantum of change will be P into AF upon MCTC. Are these issues, and then I've also explained you how we calculate GM. You have any questions on these basics which you already have covered? I have revised them, but if you have a doubt in any of these issues, let me know, guys.
सर ये GM कम कैसे होगा सर, मतलब if we discharge and in this diagram GG1 में सर?
अरे ऊपर जाना KM में से अगर kg माइनस करेगा तो GM सॉलिड कम होगा या ज्यादा होगा?
ठीक है सर, ओके, अंडरस्टूड. कम होगा सर.
ठीक है, okay. Okay, guys. So these three issues, don't forget. Don't again go in circles when we start discussing it. Now, let's understand now, guys. Another thing you must understand is whatever we are discussing today as dry docking, that applies only to the graving dock. I'm sure all of you know there are two types of dry docks. One is, let me go on the previous sheet, why mess it up here. We all know there are two types of dry docks. One, graving dock, which are basically traditional dry docks, which are cut into the land, and the dock is made. The second is the floating dock. I'm sure all of you know these things. Whatever we are going to study under the topic of dry docking will apply only to this type of dry docking. The stability of the floating dry dock is a different concept, okay? So please, if you're going to a floating dock, don't start fighting in the ship that this is what we were taught as dry docking. As per the syllabus, whatever we are studying as dry docking here we are talking about dry docking in a graving dock. Am I clear, beta? Yes or no? Clear, guys?
Yes. Yes.
Okay. Let us for the sake of clarity, what happens? All of you know, in a graving dock, when the ship is scheduled to dry dock, the ship's docking plan is sent to the ship, to the yard. What does the yard do? The docking plan tells you how the blocks have to be arranged. Now, today the ships have flat bottom, so there are three lines of blocks which are organized. One is the center line block, and other is another line on either side, each side of it, called as bilge keel blocks. I don't know if you guys have been to the dry dock or not. Now, what happens is the dry dock is emptied, then the dry dock is prepared to receive the ship by adjusting the blocks as per the docking plan. Once the dry dock is set for the ship to dock, the dry dock is filled with water, it's flooded, and the level of the water inside the dock becomes same as the level outside. Once once the ship arrives outside the dock, which usually arrives slightly trimmed by stern, we'll learn it later on why. Then what will happen? The gates are opened and the ship is floating in water. She's taken into the dock as if she berths like at any other dock. Once she's inside, the gates are closed, and then the dock is, they start pumping out the dock, make the ship sit onto the blocks, and the dock is dried for the ship to be attended to in the dry dock. Now that is how the ships are docked. Now, for the sake of easy discussion, let us consider some stability parameters before entering the dock. Okay. Let us say the ship has a displacement of 10,000 tons. Let us say her drafts are 5 meters and 7 meters. Let us say her kg is 7.5, LCG is 70 meters, and her buoyancy obviously will be equal to displacement. Why? Because the ship is floating freely as per law of flotation. So what will support the weight? The buoyancy will support the weight. Does everybody agree with me? Yes or no? The ship comes outside the dock like in this condition, correct, beta?
Yes. Yes.
Now the gates are opened and the ship is taken into the dock. Now the ship is taken into the dock like this. The black ones down below are the blocks. These are the blocks. This is the side profile. This is the bottom or the bed of the dry dock on which blocks are placed. Ship is floating. She is drawing 5 meters forward. She is drawing 7 meters aft. I don't think. Now, is there any reason for the ship's stability particulars to change, like displacement, buoyancy, LCG, kg? Do you think anything should change in this condition? No. So that means in this condition, just because she has come from outside the dock to inside the dock, her stability particulars remain unchanged and there is no change in stability. Does everybody agree with me? Yes or no?
Yes, sir.
Let us say here the depth. Let us say here the depth in the dock is 8 meters. When we say depth in the dock, we mean the level of the water above the top of the blocks. So this is what we'll call as the depth, not from the bottom of the bed, because ship is going to be stopped by the blocks. So we are not interested in the depth below the blocks. Okay. So if the ship has if the depth is 8 meters, what will be the UKC of the ship in this case, guys? Look at the diagram. 1 meter. So there will be 1 meter UKC here. Okay. Now the gates are closed and now pumping out starts. Now you have seen the ship in a tidal port. What happens? As the tide rises, the ship rises with the tide. When the tide falls, the ship comes down with the tide. Yes or no, beta? Am I right? Correct? Correct, sir. So now here, you are dropping the level of the water. It is not because of the tide, but because you are pumping out. Let us say now the depth is reduced to 7.5 meters. What will happen if the depth from 8 meters is reduced to 7.5 meters? What do you think will happen? this water level will start coming down, and with the level falling, the ship will also come down. Will there be change in draft? Do you expect any change in draft if the level is reduced to 7.5 meters, guys?
No, sir.
No, sir. If the depth is now made 7.5 meters, you don't expect any change in the stability. Only thing is the UKC, the underkeel clearance, has now reduced to half a meter. Correct, beta? Am I right? Only the UKC has reduced. Otherwise, there is no change in the stability of the vessel. Yes or no?
Yes, sir.
Now,
Yes, sir.
now I am saying the depth becomes exactly equal to 7 meters. That was the draft aft. Exact 7 meters. What will be the UKC then? If the depth becomes equal to 7 meters?
Zero.
What will be the draft aft? If the depth is 7, it will still be 7 meters. Am I right? Correct. So if the depth is now made 7 meters, exactly equal to the draft aft. Okay, let me just clear this part. Now the depth is 7 meters. Okay. Now, UKC definitely has become 0. Do you expect any change in the stability of the ship, like drafts, buoyancy, center of gravity? Do you expect any change?
No, sir.
So what has happened? Vessel has established a light contact with the blocks. Where? At the stern. So we use the word light contact. Contact is made. It is just a contact, nothing else. In a crowd, when you're standing next to each other, one person may be touching the other. It doesn't mean the other person is still pushing it. Okay, so there is a touch, there is a contact, but there is no effect of that contact on the other person when it is only just a mere contact. Am I right, guys? So here the ship has made contact with the blocks. But is there any change in the stability? No. So that means only thing change that has taken place is UKC has become 0. But UKC is an external thing. It has nothing to do with the stability. Stability remains unchanged. Does everybody agree with me here?
Yes, sir.
Yes, sir. Yes, sir. What is supporting in this case 10,000 tons of displacement? What is supporting the 10,000 tons of displacement in this case, guys?
The block.
Buoyancy.
Blocks. Block is supporting the block in somewhere. What is supporting
still this buoyancy.
Buoyancy.
I just gave you an example that in a crowd, people are standing next to each other. There are body contacts, but everybody is standing absolutely erect. That means everybody is bearing their own weight. Am I right, beta? Yes or no? Correct? Correct? So, in that case, who's bearing the weight? The legs of each individual are bearing the weights. In this case, what is supporting the displacement? What is basically supporting 10,000 tons of downward force? Tell me, guys.
Buoyancy.
Buoyancy, sir. Buoyancy. Why? Because still there is so much of underwater volume, and the weight of the water displaced has not changed. So the buoyancy has not reduced, and hence, in this case also, though there is a light contact, but the full displacement of the ship is supported by her buoyancy. Am I right, guys? Yes or no?
Yes, sir.
Guys, as the depth reduced from 8 meters to 7 meters, the water level was coming down. And with that, the ship also continued coming down. Why? Because there was underkeel clearance. Am I right? Yes or no? But now the under keel clearance has become 0. Can the ship continue going down if the level further falls? Yes or no?
No,
Will the
sir.
ship-
No, sir. It will go down.
Ship cannot go down further. The stern will be blocked by the blocks will check the stern from going further down. So what was happening was all this while the ship forward draft, aft draft remained unchanged. That means the water line and the ship in relation to each other, relative to each other, their position was same. But now, suppose I bring the depth to 6.5 meters. What will happen? This liquid level will fall, but the ship cannot go down. So now the liquid level may be somewhat like this. It will not be exactly like this, but don't worry. Liquid level is somewhat like this. Level has come down, but the ship cannot come down. So what do you see in this case? Has the underwater volume now changed? It is reduced to this green volume. Am I right, beta?
Yes, sir. Yes, sir. Yes, sir.
What has happened now? The buoyancy has reduced. Why? Because buoyancy is the weight of the water displaced. Correct, beta?
Yes, sir. Yes.
Correct? So until the time that there was under keel clearance, the falling level also kept bringing the ship down with it. But now, from 7 meter onwards, further beyond 7 meters in our example, if the level falls further, the ship cannot go down any further. So what will happen? The ship is checked, but level is falling. What does that result into? That results into reducing the underwater volume. Am I right, guys?
Yes,
Or
sir.
no?
Yes, sir.
And when the underwater volume is reduced, the buoyancy support will also reduce. Correct, beta?
Yes, sir.
Let us say this green buoyancy, let us say this green volume provides buoyancy of 9,500 tons, just as an example. It has to be less than 10,000, so let's say it's 9,500 now, when the level falls to 6.5 meters. What will happen now? 10,000 tons is the downward weight of the ship, out of which 9,500 is supported by the buoyancy. But what is the resultant now? There is a resultant 500 tons of force. Yes or no? Downward force, right?
Yes, sir. Upthrust.
You have 10,000 tons acting
Yes, sir.
downwards, and you have 9,500 provided as buoyancy. There is a resultant or net force of 500 tons acting downwards. Am I right, guys?
Yes, sir.
Where will this force exert? This force will
On the block.
exert. This force will exert wherever the ship has made contact with the block. Yes or no? In our
Yes.
example, the ship has made contact at the stern. Okay. So if the contact has been made at stern, this 500 tons will be exerted downwards by the ship on the block. Yes or no? Am I right?
Yes, sir. Yes, sir. Yes.
And what is Newton's third law of motion? To every action, there is equal and opposite reaction.
Reaction.
So when the ship exerts 500 tons of downward force on the blocks, the block will exert 500 tons of reaction acting upwards. So what will the block do? Block will exert a 500 tons of reaction upwards. Whatever force is exerted on the blocks will exert equal and opposite reaction. This reaction in dry docking is called as upthrust. And it is always represented by capital P. It is represented by capital P. Okay. Guys, what is the effect? How is the effect of this upthrust is taken into account on the ship's stability? Now, because scenario has changed, buoyancy is changed. So there will be some imbalance. So guys, this upthrust, its effect on stability is looked at in two different ways by two schools of naval architects. Both are equally good, both are equally bad. Okay. both get slightly different results. So that means the results are not accurate for either case. Okay. But both are, as I said, equally good or equally bad. One school of thought, we will follow the school of thought which connects to our earlier learning better. So why I'm choosing the one I'm going to teach you is because what it will connect better with what we already know. I'm not saying that what I'm teaching you is better than the other. Please don't misquote me anywhere. I'm saying both are equally good or equally bad. We are going to follow the one which is easier for us to understand. Why? Because we already have a certain base on certain issues or certain aspects. Now, the one school of naval architects feels that this upthrust P, when I was making the line diagram, how was I representing the discharging? If you remember, I was representing the discharging like this, correct?
Arrow upward, yes, sir.
What was discharging doing? It was causing an upward force at that point, correct? Am I right?
Correct.
Discharging was causing an upward force at the point, right?
Yes, sir.
And likewise, an upward force called as upthrust is caused here. So one school of naval architects takes this as if P tons is virtually discharged, imaginarily discharged. Towards as shift of kg. Why? Because actually the kg has not shifted. This is a virtual shift. So we don't want to get confused between where is the kg of the ship, where is the virtual kg of the ship. That will lead to confusion. So to avoid that confusion, instead of calling it as a virtual rise of G, virtual rise of G will lead to reduction in the GM. So this virtual rise of G will actually lead to then virtual loss of GM. Virtual loss of GM. Is that clear? You told me that if the G rises up, it is as good as the GM becoming less. Yes or no? Correct?
Yes, sir. We can say virtual loss.
So instead of allowing it to the kg and getting confused between actual center of gravity and virtual center of gravity, this effect on kg, virtual effect on kg, is not spoken as the rise of G. It is being compensated as virtual loss of GM. So instead of calling it as a rise of G, we call it as virtual loss of GM, because ultimately, if I raise the kg, that will also reduce the GM. Or if apply this as loss to the GM, it will again reduce the GM. So effect will be same. So instead of creating a confusion about real kg, virtual kg, this kg, that kg, we say kg of the ship is the kg of the ship. Let us take this virtual increase in the kg as virtual loss of GM. Is that understood better? Is that clear?
Yes.
Guys, speak up if you have not understood something.
Yes.
Sure? This is virtual loss of GM. So the formula for virtual loss of GM will be P into kg upon W minus P. If you have learned something else in your MTIs, once you are doing with me, I would suggest to switch over to this one. You'll find it easier. But if you still want to continue with that, I have no objection on that. Only thing is, your answers will not match with the class. That's all. Rest, everything is fine. So that method is also correct. I'm not saying it's not correct. So guys, here, because I have introduced a virtual rise of G, virtual loss of GM, I have spoken something. So what I would do now is, I'll give you 5 minutes break. It's 1848 till 1855. You please review this, what I have told you, review the effect, and let me know if there is any concern. At 1855, I'll continue with it and see that you're okay with this virtual loss of GM. If there is any concern, let me know immediately after the break. Is that clear, beta? Okay, then I'll mute myself, and 1855, we continue. By then, please review what I've, and you want to have a cup of tea or water, please have that. Or there is still some doubt which needs more explanation.
Sir, one small doubt, sir. अभी
Yeah,
यहाँ
tell
पर
me.
kg will be decreasing or increasing, sir, once we
You tell me if you discharge from keel something, will the kg increase or decrease? Though not really, but virtually. If you discharge something from keel, will the kg rise or?
So kg will rise, sir.
Kg will rise. That is why this GG1 had upward arrow, but it is not called a shift of kg in dry docking. We allow it. It is the same effect, but it is not allowed to kg. It is allowed to GM, and hence we call it as virtual loss of GM, right, beta?
Yes, sir. This recalling, sir, once the kg increases, so GM will also increase, sir.
GM will decrease by km minus kg.
Km minus kg.
So if it
yes, okay,
GM is
okay sir, km minus kg, ठीक है sir, GM negative भी जा सकता है तो, ठीक है.
So let me clear this now, or let me go to the next one. No issues. I'll do on the next slide.
Sir, can you also explain this Km formula briefly? Because
I explained at the beginning of the class.
सर ये जो V loss का Km वाला जो formula है वो. Sir,
No, I'll not be creating confusion by parallelly doing both. No. I don't do that in the class. Because if we operate with parallels, then everybody will say, so can you solve both the questions both ways, all the questions both ways? Okay, that will not happen, Akshay. If you want to continue with the other one, it's up to you. It's your choice. But it's not possible to cover the content with both the methods here. Okay, that is P into Km upon W, right?
Yes, sir.
So you want to use
just
that?
one thing. So this kg will be initial kg, or we will take this for W minus P?
To remove this confusion only, that how many kgs are there, now there is only one kg. Has the kg of the ship actually changed? Have you actually discharged something?
Okay. Understood.
You have not discharged any weight. So the kg of the ship can only change in three cases. One, you load something. Two, you discharge something. Three, you vertically shift something. These are the only three things which can cause the kg to actually change, right? And since none of these three things are happening, so the kg of the ship is not being touched, and therefore this GG1 upwards, which came by the GG1 upward formula, is not applied to kg. This is called as virtual loss of GM. Is that clear?
Yes, sir.
So we say in Drydocking under this concept. Which concept? Where upthrust is assumed to be the weight virtually discharged from point of contact. That leads to a virtual loss of GM. And what is that equal to? P into kg upon W minus P. Now, why I prefer this method is because you know how this formula has actually come. Otherwise, you see, just doing the formula, either I take the derivation of that formula and then make sense out of it, The other formula, I'll just give you an overview, is based on the fact that now buoyancy has reduced to W minus P, and this buoyancy W minus P is acting upwards, and this P is also acting upwards. So they are saying this is acting as a supplementary buoyancy. So when buoyancy of W minus P is provided by water, P buoyancy is provided by the blocks, the total buoyancy becomes W minus P plus P equal to W. That is the other concept which we are not going to go into. For us, since we are all familiar with this discharging concept, when you do the questions, you will realize how simple it becomes if you follow this method, because it connects with what you know. Not that the other method is too difficult to follow, but that method will not connect with your prior learning. This will directly connect with what you know. So the virtual loss of GM under this method will be P, the upthrust, into the kg of the ship. Ship has only 1 kg in dry docking. That is our actual kg upon W minus P. Is that clear, beta?
Yes, sir.
Yes, yes.
Second, now tell me, guys, in our example, we said that the displacement was 10,000 tons. Then we said, okay, at 6.5 meters depth, we said, let us say the buoyancy is 9,500 tons.
Just one doubt, sir. One small doubt, sir. This virtual loss of GM, sir, it is the GM solid, right, sir?
It is virtual loss of GM. It is, when you apply FSC, it is also a virtual loss. This is one additional loss of this is another component which is lost.
Okay, sir.
See, the GM will suffer all the losses which it suffers, right? So this is one of the additional losses which only occurs if the ship goes to dry dock, right?
Copy.
So this is an additional loss which has happened because of the dry docking process, which would not have happened if the ship was freely afloat, right?
Yes, sir.
Okay. So in this example, guys, where we said displacement was 10,000 tons at 6.5 depth, buoyancy was 9,500 tons, just for example. How much is the value of P here then? How much is the weight transfer to the block? 500 tons. So buoyancy upthrust here will be in our example 500 tons. Now tell me, guys, from 6.5, if the level goes to 6 meters, will the buoyancy reduce, increase, or remain same now when the level falls further to 6 meters now?
Buoyancy reduce.
If buoyancy decreases, then will the P increase or remain same? P will increase. Because buoyancy support is reduced, more weight going to the blocks exert more reaction. And if P is increasing, will the virtual, look at the formula, will the virtual loss increase or decrease? Increase. So as the level keeps falling, the virtual loss of GM keeps increasing. And the problem is, this is why you need to be careful that you should not become unstable. But somewhere the vessel will become unstable because ultimately will be drying up the ship. So first tell me, when did the loss start taking place? We did many stages. One, she entered, then level came to 7.5, then level came to 7 meters, then level came to 6.5. In our example, when did the virtual loss start? Or when would the virtual loss start?
When the cave touches
virtual loss will start when upthrust comes into picture. When will upthrust come into picture? Only after the first contact is made, right? First contact with the blocks is made, right, beta? Correct?
Correct.
Yes,
So that means the virtual loss of GM because of dry docking will start only when the vessel makes first contact with the blocks. Until the time she had not made the contact, she was totally floating with the same stability as she was floating outside the dock. Now, once she has made the contact, with the following further fall in level, the upthrust will keep increasing the virtual loss of GM. And this virtual loss of GM poses a threat to the vessel because we know if the GM becomes negative, vessel becomes unstable. But, and if vessel becomes unstable, she can topple sideways. Now, if you look at what will happen to the trim component, you see with the line diagram I explained you. If P tons is virtually discharged from here after perpendicular, a center of rotation, then we all know that when P tons is virtually discharged from here, what is it going to do to the trim? It will cause a change in trim by head. Am I right?
Yes, sir, yes. Yes.
And what will be the change in trim cost? It will be P into AF upon MCTC. Yes or no?
Yes, sir.
And this change in trim is by head. So guys, the vessel initially entered with a trim of 2 meters by stern, 5 meters and 7 meters. But now the P is causing a change in trim by head. So will the trim of the ship keep reducing or will it remain same? Tell me. As the P comes into picture, P is causing a change in trim by head.
It will keep
Reducing. So suppose vessel entered initially with 2 meters of trim by stern. Then you have 500 tons of upthrust acting here. Let us say 500 tons causes a change in trim by 50 centimeters by head. That means now the trim will become 1.5 meters by stern. Yes or no? Yes, correct, Peter? Then what will happen? The level will fall further. P will further increase. As the P increases, change in trim will be more. That means the trim by stern will reduce. Look at the diagram. So what will happen? The trim by stern will keep reducing. And what will happen when the trim becomes zero? Look at the diagram. What will happen when the trim becomes zero? She will make contact with the blocks all over, right?
Yes, sir.
Yes, sir.
Why is the ship only at a single point contact in this diagram? Because of trim. If there was no trim, she would have been sitting complete overall. Yes or no?
Yes, sir.
Why did the ship make contact at the stern? She made contact at the stern because the UKC was at stern was the least, because the vessel was trimmed by stern. So if trim by stern was responsible for 1 point contact, so what will happen if the trim by stern vanishes? She will make contact all along the block. Am I right, Peter? All along the length?
Yes, sir.
Yes, sir. Yes.
Correct? When she makes contact all along the length, then look at the cross-sectional view of a dry dock, graving dock. This is how a graving dock is. You have centerline blocks and you have the side bilge keel blocks. So you have another set of one block on this side and another block on this side. You see, until the time the ship sits completely, she is on a single point contact at the stern. But when she sits completely, what will happen? Now the ship will be sitting on the blocks like this. Correct, Peter? This is how the ship will be sitting in the dry dock once she takes to the blocks overall. Correct? Am I right?
Yes, sir.
Yes, sir.
When she makes contact with the side blocks, is there a risk of ship tilting sideways? Can the ship now tilt sideways?
No, sir.
No, sir.
That means now, if she goes into unstable equilibrium, her GM becomes negative. Can she topple sideways?
No, sir.
Yes, sir.
No, sir. No.
No, sir.
How will she topple? The blocks are supporting her. This block, if these blocks will not allow her to topple. Yes or no? Am I right?
Yes, sir.
Guys, in the olden times, when the keels were narrow and the ships were like this, then when the ship came to in contact all over, then it was supported by side shores so that she does not topple on the sides. Now, because you have flat bottom ships, these shores are not required because these bilge keel blocks will support the ship. So that means my ship does not have a risk of tilting sideways after she sits on the blocks completely. Am I right in my statement? My ship does not have the risk of tilting sideways when the ship sits on the blocks completely. Am I right, Beta?
Yes.
Okay. So that means after she sits completely, even if the GM becomes negative, let it be. Because the ship is supported, she cannot fall sideways. So that means when did my risk start? My risk started risk in terms of what? Loss of GM. My risk started when vessel made first contact with the blocks. Correct, Beta? That is when my risk started. When does my risk of tilting sideways ends? When vessel takes to the blocks all over. Correct, Beta?
Yes, sir.
This period, from the time she makes first contact to the time she sits completely on the blocks, is very, very critical for dry docking. Why? Because during this period, if the GM becomes negative, vessel will topple sideways. Therefore, this period is called as critical period. This comes in theories sometimes describe critical period. Critical period in dry docking context is the interval of time or the period between the vessel making first contact with the blocks to the time she sits on the block all over. This interval is called as critical period. Understood, Peter? Understood?
Yes, sir.
And why is it called critical period? Because in this critical period, if the GM becomes negative, vessel will topple sideways, and therefore this period is critical. You do not want the GM to become negative during this period. Once she sits completely, then the GM becomes negative. It does not bother us. Is that clear, Beta? Am I right?
Yes, sir.
Yes, sir.
Okay. Now, so critical period starts at point one, that is first contact. It ends when the vessel sets overall. During this critical period, that means at first point, at second point, or in between. This is the critical period. In this critical period, when is it most dangerous? Is it most dangerous at the beginning at number one? Is it most dangerous towards the end at number two of the critical period? Or is it most dangerous somewhere in between of the critical period? When is it going to be most dangerous?
Towards the number one, sir.
Towards the end, sir.
Why?
Towards the end.
Okay. Somebody who said number one. Can you tell me why do you think it will be worst case scenario in number one? Tell me, Beta, why do you think number one is
Sir,
the
in
worst
my
case?
opinion, because at point one, she is subject to topple both ways, sir. That's why.
No, in number two also she can topple both ways. In between also she can topple both ways. Why
Sir,
she cannot? What do you mean by both
because
ways?
sir, in number one, she is only touching one block. So relatively, she should be
how
more.
many points is she touching here? How many points is she touching here?
In between सर एक से तो ज्यादा ही है तभी वो थोड़ा
कैसे
safe
कैसे
होगा।
एक से ज्यादा कैसे है बताओ? एक से ज्यादा कैसे? एक से एक मुझे बताओ
क्योंकि पानी पंप आउट होता जा रहा है ट्रिम कम होता जा रहा है
सो ट्रिम कम होता जा रहा है तो क्या हो गया? अगर ये बीम एक ऐसे स्ट्रेट है, ठीक है, अब तुम चाहे कितना भी इस बीम को कर लो, अगर ये एक पॉइंट पे कांटेक्ट पे है तो पूरी बीम दूसरा पॉइंट कांटेक्ट कब करेगा? जब बीम हॉरिजॉन्टल होगी तभी कांटेक्ट करेगा ना। ट्रिम कम होने से क्या हो जाएगा?
इम्पैक्ट कम हो सकता है।
Did I ask you about impact? When she falls sideways, there will be one impact only, that she'll topple sideways. There is no other impact. Okay. Sideways falling, what do you mean by less impact? Uda?
Yes, sir.
What do you mean by less impact? We are not talking vertical fall. She'll topple sideways, my friend.
Yes, sir.
So sideways, what do you mean by less impact?
That water level is now reduced so that. ठीक है, sir. It does not make sense.
So now tell me which point will be the worst case scenario.
Number 2, sir.
Just before she touches all over.
Very good. Since this is the worst case scenario, why? That she's still on single point contact and she has experienced the maximum loss of maximum virtual loss of GM during the critical period. Of course, loss of virtual GM will keep increasing after the critical period also. But during the critical period, maximum virtual loss is experienced here and vessel is not adequately supported. So that means this is the most dangerous instant or the point or the scenario. And this is called as, again, a technical term, critical instant.
Second, the vessel is sitting, takes block of
no, better. There is a difference. At 7 meter draft, in 7 meter depth, in our example, the vessel had made contact with the block. But was there any upthrust in that case? Yes or no? Do you recall that situation?
Yes, sir. Slight upthrust.
At 7 meter depth, was the upthrust there?
No, not at the 7 meter.
So light contact was made, but there was no effect of that, correct?
Yes.
Am I right? So that means that contact did not affect the stability of the ship. Am I right? Why?
Yes, sir.
Because the block had not taken any weight. Am I right?
Yes, sir.
Okay. So when the vessel just sits on the blocks, you see the word just sits on the block means that the vessel may have made contact all along the length, but the weight has not been taken all along the length like what happened at 7 meters with the stern making contact. Correct, Vita? Is that clear? I'll tell you something. Suppose on a spring balance, you have a table like this here. You have a spring balance here, and you put a weight, let us say 20 kg on this. What is the dial showing? 20 kg. Now you keep lowering this. So your this clearance is reducing. A stage will come where the block will make contact with the table lightly, but the gauge is still showing 20 kg. Correct, Beta? Am I right?
Yes, sir. Yes.
What has happened? Touch has been made, but table has not taken any weight yet. Correct, Beta? Touch is made, but the block weight has not been taken. The way I told you, in a crowd, somebody may be touching you, but neither his weight is coming on you nor your weight is coming on the other person, right? Correct?
Okay, sir.
But when the crowd, somebody pushes, what happens? The weight is transferred to the next person. Am I right?
Yes, sir.
So now, if you bring the balance further down, what will happen? Maybe it starts showing 15 kg. That means what happens? 5 kg has been transferred to the table.
Yes,
if you
sir.
completely release it, the entire 20 tons will be taken, 20 kg will be taken by the table, correct? So when the vessel makes first contact all along the length, it is similar to vessel making first contact at the stern at 7 meters depth. That means contact is made, weight has not been taken by the blocks all along the length. So we call it as just sitting overall. The word just means there is a light feather contact, but that contact has not made any effect to the stability because the blocks in the forward part, midship part, elsewhere along the length are yet to take the weight of the ship. Is that clear, beta?
But sir, when the stern touches the block, so the weight is transferred. मतलब जैसे 6.5.
I asked you at 7 meters draft what was happening.
Okay, sir.
Was contact made?
Slight contact, sir.
Was there contact made? Yes or no? There is only yes or no. There is nothing
No,
like
sir. No.
Contact was not made at 7 meters. Then
Yes,
why
sir.
did UKC become zero? At depth of 7 meters, why did UKC become zero if the contact was not made? Inder?
सर मतलब कांटेक्ट स्लाइड कांटेक्ट तो हुआ था ना
I am asking, was contact made, yes or no?
yes sir, contact was made to the block sir.
But did it impact the stability of the ship?
No sir, because buoyancy was floating the ship.
Correct. So there was a light contact. We describe it by the word light contact, that there was a contact made, but it did not change the stability, correct?
Yes sir.
Similarly, when the trim is reducing, there will be a stage where the vessel makes light contact all along the length, but still, technically, it is at a single point contact only. Why? Because elsewhere the weight has not been transferred, right?
Transferred fully, yes sir. Yes.
Correct?
Yes.
So guys, what is critical period? Critical period is the interval of time or the period in dry docking from the time when the vessel makes first contact with the blocks to the time vessel sits on the blocks completely or takes to the blocks all over. That period is called as critical period. What is critical instant? Critical instant in dry docking is the instant or is the moment when the vessel just sits. Just word is important, not sits, just sits. Just sits means makes light contact with the blocks all along the length. Is that clear, beta? Light contact means technically the weight is still at single point contact only, but she has made a light contact all along the length, and that is the critical instant. Understood, guys? Clear, class?
Yes sir, yes.
And why is it called critical instant? Somebody may ask you on orals. It is called as critical instant because in the critical period, in the validity of the critical period, during the currency of the critical period, at critical instant, the vessel would have experienced the maximum virtual loss of GM. P would have been maximum for the entire critical period. Now somebody may ask you, then what happens after that? Will there be no virtual loss? Virtual loss will continue after the critical period also. But then it does not bother you because the ship cannot topple sideways. Is that clear, beta? Because she is adequately supported. Am I clear, guys?
Yes sir.
Yes, sir.
So sir, virtual loss of GM will be more at the critical instant. मतलब before just she is going to sit on the blocks.
Up to that, in the critical period, maximum the maximum virtual loss will be at critical instant.
Okay.
So I'm not saying maximum loss is at critical instant. I'm saying during the critical period, maximum loss is at critical instant. The virtual loss will keep increasing after she sits also, right?
Yes sir, yes.
It's not that virtual loss is going to vanish. Virtual loss will keep increasing as the P further increases. But then it stops bothering you, right?
Yes sir, yes.
Correct, beta?
Yes sir.
Okay. So now, what will be our challenge in the questions? Our challenge in the questions will be how to get P. Now, there are two ways of getting P, guys. And there are only two ways. One we just saw, that when we had a displacement of 10,000 tons, we had buoyancy of 9,500 tons. We said P was 500 tons. That means at any stage, if you know the displacement of the ship is the displacement of the ship, guys. In dry docking, there is no second displacement. There is only one displacement of the ship. Why? Because actually no weights are loaded, no weights are discharged. Whatever P we are treating, we are calling it as a virtual discharge. It's not actual discharge. So this displacement minus buoyancy at any stage. If we can get the buoyancy and we know the displacement, the difference between the two will be the upthrust. Yes or no, beta? Am I right?
Yes sir.
The second was when P is acting at the after perpendicular and your center of flotation here, then trim change was P into AF upon MCTC. So if you know the trim change that has taken place, you know the MCTC and you know AF, you can get P is equal to trim change caused in centimeters. Remember that, into MCTC upon AF, and that will give you the P. Yes or no, beta? Correct? So one way of getting P is this one. This is the other way of getting P. But the second method, what is TC? What does TC stand for?
Trim cost or trim change?
Trim cost. Very good. Trim change or trim cost. Guys, is there going to be any trim change after the critical period? After the critical instant, is there going to be any further trim change once the ship sits on the blocks completely?
No, sir.
No, sir.
So that means, so for this TC formula to be used, there has to be trim change, right? Correct?
Yes, sir.
TC, as the name suggests, is the trim caused or trim changed, right? So for this formula to apply, there should be a change in trim. And change in trim does not happen after the critical instant. Why? Because then the ship is sitting completely on the blocks. There is no further change, right?
Yes,
Correct?
sir.
Yeah, right.
So this second formula applies only when there is a change in trim. And when does the change in trim happen? It happens only during critical period. Right? So the second formula can be used only during critical period or during the period when the trim is changing. The first formula can be used any time of the dry docking. The first formula can be used at any stage of the dry docking. Am I clear, guys?
Yes.
Clear? Okay, this I've explained, so there's nothing to worry about. Now, this I've done. That's okay. This all has been explained. This is done. Don't worry. Done. Okay. How to obtain P? I just told you there are only two ways to get P. One, before the vessel takes to the blocks by overall. That means blocks overall means this phase is the critical period. During the critical period, it is by change of trim formula. You can use it. And what is that? And at any instant, including the critical period, you can always find it with the difference in the, you don't call it as initial displacement, difference between the displacement of the ship and the buoyancy support. Let's put it correctly. And the buoyancy support available at that time. So it is W minus B. These are the only two ways to get P, and we'll be able to solve it. Once we get P, then we have to find what is the GM of the ship. And what do we do with the GM, guys? I have described critical period. I have described critical instant. You know it. Now, virtual GM calculations. We know if outside the dry dock, how the GM would have been calculated. KM minus KG, GM solid minus FSC, GM fluid. This would have been the GM if the ship was not in the dry docking process. But in the dry docking process, there is an additional loss of GM which comes into picture, which will virtually further reduce the GM. So the GM calculation shall be Km for W minus P. Now you'll say why this Km should be taken for W minus P. Guys, in your hydrostatic tables, the Km is given against the draft. Am I right?
Yes, sir.
Correct. So when the water level keeps falling and the ship cannot go down, she has made contact with the blocks. Are her drafts changing? Yes, the draft starts reducing after that, correct? Am I right?
After critical period, yes, sir.
After
Not critical period, when the start, after the contact is made and the level starts falling.
Yes, sir. It reduces.
So if the draft starts reducing, the Km should be for the reduced draft, correct?
Yes,
Because
sir.
Km depends on water plane area and KB, correct, beta?
Yes, sir.
So there, and what does the draft correspond to? That will correspond to the virtual displacement W minus P. Why I'm calling it a virtual displacement? Because P is virtually discharged. So the virtual displacement will be W minus P. So now you understand why Km should be taken for W minus P. Is that clear? Or anybody has any doubt? Km should be always taken for W minus P because Km from hydrostatic tables we know depends on draft And once the vessel makes contact with the blocks, the draft starts reducing. And if the draft starts reducing, the Km will change. So Km should be taken for W minus P. Minus Kg, this will give you the GM solid. Minus FSC. Now guys, what is the formula for FSC? FSC is equal to FSM upon W. But in my case, the method that we are following, what method are we following? We are following a method in which P tons is virtually discharged, correct? If P tons is virtually discharged, has the ship's virtual displacement reduced? Yes or no? Actual displacement is not reduced, but has the virtual displacement got reduced?
Yes, sir.
Yes, sir.
Yes. So this will be W minus P. So FSC will be FSM divided by W minus P. This will give you GM fluid. And now, because you're talking of dry docking, there'll be another loss of GM, virtual loss of GM. Formula for which we are going to use is P into Kg upon W minus P. And the GM we are going to get, we'll call that as virtual GM. So this will be the process flow to get the virtual GM, for which first thing would be getting the P. Please review it. Let me know if you have any doubts. And while you're thinking over it, also do one thing. You can also have the MV in ship stability booklet ready. I'll share with you certain questions. We'll start discussing the questions now. We are already at a stage where we can now take the questions. And I need to do at least 2 questions today, and so that it sets rolling. And by tomorrow end of the class, we'll all be okay. So don't get panicky today. There may be some doubts. Don't try to overexert yourself today by taking up questions. Today, what your focus should be only on revision of what has been done. By end of the day tomorrow, you will be reasonably well placed, and then you will be able to make better sense out of things. So do not just unnecessarily get worried better that because first day there can be some people who may have some apprehension, some doubts, and all those doubts will address tomorrow. They'll all be taken care of. Don't worry. And we are not going to pick up speed. Okay, 4 classes are more than enough. If the need be, there can be more classes. So don't worry about it. Guys, I've shared some 5-6 questions with you. And I'm going to take the first question. You don't have to open that. Question will come here on the display.
सर एक बार पिछली स्लाइड में सर W minus P पूछना था कुछ सर.
क्या पूछना बताओ?
Sir, will be calculating in the MV inch once we get the जैसे W में से P minus करके will be calculating.
देखो अब तुम MV इंच पे मत जाओ मत अभी. अभी जो बताया सिर्फ उतने पे रुको.
Sir, W minus P में से जो value आएगी we have to calculate the Km for that particular, right?
Yes, beta.
And for the FSM, it is the FSC upon W minus P. Sir, वो जो buoyancy आपने बोला virtually वो भी loss होगा सर. वो थोड़ा सा doubt आ रहा है.
कौन सा virtual buoyancy loss होगा?
Displacement once you told us कि.
So what are you treating in our discussion P as? What are you treating P as?
Virtual loss.
Virtual loss. Okay, virtual loss. Okay. Virtual loss or virtual discharge?
Virtual discharge. मतलब something is discharged.
So if you virtually discharge something, really, you have not done anything. So will the vessel virtually be light? Yes or no?
Yes, sir.
Correct?
Yes, sir.
Am I right?
Yes, sir.
I'll give you a simple example. If you have a weight, okay, and you try to lift it on ground, you'll have to put some force on it. Am I right, beta?
Yes, sir.
When you put the same weight in water, assuming it does not absorb water, now the weight will have some dimensions, right? Some volume. When you lift that weight in water, will you be putting the same force or lesser force to lift it in the water?
So lesser force.
Why? Your answer is correct, but why?
Buoyancy.
Buoyancy, yes.
Buoyancy. Buoyancy. Okay. So why are you putting lesser force? Because the buoyancy is causing the upthrust, right?
Yes, sir.
Right. So it is basically the body has virtually become lighter. Its weight has not reduced. You've not loaded, removed anything from here. But the body has become virtually lighter. So you're applying lesser force. Am I right?
Yes, sir. Yes.
So now if you have to tilt that body, it will be easier to tilt, right?
Yes, sir.
So if your ship has also become virtually lighter, then the liquid, when it shifts from one side to another in the slack tank, it will have greater effect because the ship has become lighter. It is FSM upon W. Now the weight has virtually become lesser.
Yes,
correct?
Understood. Okay, clear. Thank you.
Guys, if you understand it, you will not forget. I can tell you this. Now look at this question. Please have your hinge ship stability booklet ready. MV hinge ship enters seawater dry dock, drawing 6.2 forward and 8.2 meters aft. Guys, in one or two questions, first I'll tell you what to interpolate because I don't want you to waste time interpolating everything. But from tomorrow onwards, you will have to think which particulars are you going to require. So that when you read the question, you should also think what all do I need to solve the question so that I don't waste time in interpolating all the 8 particulars, nor do I interpolate less and time and again waste time going back and forth between the particulars. So you'll have to learn this, and if you have a problem, let me know. So MV Inship enters a seawater dry dock drawing 6.2 and 8.2 meters aft, kg 6.1 meters, FSM 1200 ton meter, when she is just about to take to the blocks. Now you see, guys, when she is just about to take to the blocks means what? It's the critical instant, yes or no? Critical instant, yes, sir. So you see, even if these words were not there, still you should be able to make out that this means critical instant. Am I right, Beta? Correct?
Yes.
So that means he wants you to calculate the virtual GM at critical instant and the moment of statical stability at 1 degree angle of heel. Now, please, first all of you, for these particulars, can you please calculate the initial height draft and let me know the initial height draft? I have it on my slide. I don't want to take you through. You have to calculate parallelly, guys. Please calculate the initial hydrostatic draft. $7.203. Okay. Is he right, guys? Can you confirm?
7.2022.
Okay. Round up to 3 decimal. 203. Okay. 2 confirmations. How about others? Now, you guys, if you are not able to calculate height draft, then you're naturally not going to move further. And that is why we spent the 2 sessions earlier talking about all this. Otherwise, today half the class would have said, "Can you teach us how to calculate?"
7.2026 मतलब 7.203 sir.
Very good, Shabash. Very good. Anybody has any doubts? You will get the mean draft. You'll get the LCF from hydrostatic tables for it. And then you will apply this and it is 7.203. Does everybody agree with me that the height draft is 7.203? Anybody in the class who's still struggling, and if you're struggling, you need to, guys, pull yourself up, otherwise you'll just lag behind. For this height draft, can you please interpolate these particulars? Always make a column for density and draft and then interpolate these 3 particulars, please. In MV Inship, AF is called as LCF, so it's the same. Please interpolate all these 3 particulars.
So can you please repeat sir? मेरा net lag हो गया था sir. Last
कुछ नहीं,
sentence.
height draft के बाद ये particulars interpolate करो.
Okay.
Guys, those who are using P into Km upon W, my suggestion would be stop using it. You'll find it much easier to handle with this. But if you still want to use it, that's very much accepted with. There's nothing wrong with it. In fact, most of the MTIs teach using that one. But somehow I feel for students, this is much better. Have you been able to get the particulars, guys? I'll show you. Please confirm that you're able to get the particulars. Yeah.
Sir, one doubt, sir. Sir, can we take directly for 7.2? That is very negligible, 7.203.
No. Okay.
Okay, sir.
14767.9. It's already come on display, beta. Round displacement will round off to 1 decimal place, all other particulars to 3 decimal places. The values are on display for you to match now. We have discussed the interpolation in the first class. I don't think that should be a problem.
Yes, sir.
Anybody who's still interpolating and wants me to wait, you'll have to tell me to stop. I don't mind waiting, but
Yes, sir. One minute, sir. 1 minute.
okay, please. Once you're done, please let me know, because otherwise you'll miss out on what I say.
Sir, LCF is 71 decimal 396.
Is it 396? Can somebody class in the confirm 396 or 390, please?
390.
Please check your interpolation better. Please check your. See, this is where you'll start realizing your mistakes also. Maybe there are some mistakes I may also made. That's not the issue. But these have been validated by batches, so they're unlikely that the mistake would be here. Okay.
Done, sir. Done.
Done. Okay. Guys, what does the question want? Question wants what will be the virtual GM at critical instant? And if you recall the sequence of things, Km for W minus P, for which you need P, minus Kg. Kg is given in the question, no issues, which will give you GM solid, minus FSC. FSC, FSM is given in the question, divided by W minus P, you will need P. That will be GM fluid. Minus virtual loss. That means P into Kg upon W minus P, you again need P. So basically, if I get P at critical instant, my problem for the first part will be solved. Am I clear, beta? Am I okay in saying so?
Yes, sir.
Clear, sir.
So that means my aim is to get the P, the upthrust, at critical instant. Guys, at critical instant, can we use, okay, one way to get P is W minus B. Well, W we can have 14768.0, but we do not know the drafts at critical instant, so we cannot get the buoyancy. So that system does not fit in. Second option is trim change. Is the trim changing up to the critical instant? Answer is yes. Why? During the critical period, the trim keeps changing. Now, what is the trim of the vessel on entry? That is 8.2 minus 6.2, 2 meters by stern. You can see it here on top. It's 2 meters by stern. What will be the trim at critical instant, guys?
Zero.
So what will be the change in trim at critical
2 meters.
instant? 2 meters by head. Correct? So we have to use the trim in centimeters, mind you. So using the formula, trim change is equal to P into LCF upon MCTC. We have MCTC, we have LCF, we have the trim change. Can we find P at critical instant? How much is P at critical instant? Can you calculate how many tons is it?
So 522.311.
Okay, you can keep it up to 1 decimal. All weights you can keep up to 1 decimal place. Okay, beta?
Okay, sir.
Okay, P at critical instant. I'm sure you will agree with me. Trim change is equal to P into LCF upon MCTC. which implies P is equal to trim change in centimeters, is 522.3 tons. Does everybody agree with me?
Yes, sir.
Any questions on getting the upthrust at critical instant, guys? All good?
Yes sir. सर वो दूसरा मेथड जो P वाला था
मैं
डेटा
नहीं करूंगा बीच में दूसरे मेथड की बात.
ठीक है.
I will not go that route. You can keep asking 20 times.
Okay sir.
जो मेथड तुम्हें एक समझ में नहीं आता दूसरे को साथ में ले आओ फिर उसके बाद खिचड़ी बना दो. ठीक है? Okay guys. Now once you have this P, you need Km for what? You need Km for W minus P. Am I right? Correct?
Right, sir, right.
So please interpolate Km for W minus P. See the table, density, seawater, find W minus P and find the corresponding Km. Put the values and now you'll interpolate against displacement from the hydrostatic particulars. And once you get this value on display, please let me know, then I'll proceed further. Everybody's got 8.261 guys. Anybody has any doubts?
No doubt.
Now we start with this. I usually make it a table. If you don't want to make a table, it's your choice. No issues. You can do it simply. So Km for W minus P is 8.261 here. From here, we'll subtract the kg. Please write down GM solid. That will give you GM solid. That will be 2.161 meters. Am I right?
Yes, sir.
Okay. Next, from here, we'll subtract the free surface correction.
0.084.
Very good. And I have in the remarks, I've shown the calculations in the exam. I can show it here so that I don't have to run here and there to demonstrate how I got it. FSM upon W minus P 0.084. That gives you GM fluid. Okay. Now, once you have the GM fluid, now last you have to apply is the virtual loss P into kg upon W minus P.
0.224.
Yes, and the virtual GM is 1.853. That is the answer A to the question. So whenever you have to find virtual GM, please tell yourself you have to find P. How you find P, that will depend on how the information is given in the question. But unless you find P, you will not be able to find the virtual GM. Is that clear, beta? This is the virtual GM at critical instant. And this is sufficient GM. This is sufficient GM. 1.853 is a sufficient GM. No issues. Guys, if it is okay, I can take the part B of the question, or you're still trying to understand or do something out here. The second part of the question says, find the writing moment at 1 degree angle of heel. Guys, this has nothing to do with Drydocking. The writing moment we know is W into GZ normally when we talk about it, right? And for small angles of field, we take GZ as GM initial sine theta. That is for the normal cases. Now in Drydocking, which method are we following? We are following the method where we are assuming that the upthrust is the weight virtually discharged. So what has happened in Drydocking? My weight has virtually reduced to W minus T, correct? And my GM fluid has got reduced to virtual GM, correct, beta? Am I right? Into
Yes, sir.
sine theta. Sine theta, theta is given in the question 1 degree. So writing moment will be equal to W minus P because P tons is virtually discharged into the GM, which has now got reduced to 1.853 into sine of 1 degree. And units of writing moment will be ton meter because displacement is in tons, GZ is in meters. So writing moment is in ton meter. And you can find the value, the answer is 460.7 ton meter. 460.7 ton meter. Is the first question clear to everybody, guys? Or you still have any doubts? Let me know.
The moment of statical stability at 1 degree heel में यही निकालना है writing moment.
होता ही writing moment है, moment of statical stability है.
ठीक है.
तो वही निकालोगे ना बेटा जब वो the writing moment is the moment of statical stability, right?
जी.
Correct. Okay.
Yes.
So technically, when we are Drydocking, these things come into the picture, the writing moment.
It does not.
Sir,
GM
one
itself is.
small note, sir. Sir, like in this question, draft forward and draft aft is given. So for finding initial LCF, we use the mid draft, but that mid draft is not the center of flotation, right? So why we take that?
Were you there in the class when we discussed how to get the height draft?
Yes, sir, I was there.
So we used the MV inship question to find the height draft of MV inship, yes or no?
Yes, sir.
So what is the change from there to today? Is there any change?
Sir, very minor change.
What is the change? There's no change. There also we took the mean draft and took LCF. Shall I open that slide? What is the minor change? I don't see any change.
Like sir, our high draft was different,
one
right?
second. Don't shift the goalpost because I waste more time in taking people back than just entertaining questions which have no head or tail. Because you can't be going back and forth on the same issue, my friend. In this very first lecture, what did we do here, my friend? Can you see this on display?
Yes, sir.
Were you in the class that day? Did I ask you to revise first 4 or 5 questions of MV inship?
Yes, sir.
Did you revise? No, sir. And that is why you'll have a problem. Now you understand?
Yes, sir.
So please put in some effort after the classes get over. Is there any change in what we'll discussed here vis-a-vis what we are doing today? Just tell me. If there is a change, then tell me.
No, sir. No.
So then why this doubt is coming up today?
No, sir. I revised, but I forgot this one.
No, you have not revised. Somebody who revises does not forget. Okay, so stop fooling around. That's why I don't cut short, beta. I do by basics. If I teach you GG1 upwards and I start with that and I start with KG moving up down, so I don't leave it to doubt. But if you don't want to listen and don't want to revise, then you'll be loaded with doubts only. Okay. Guys, second question I would like to skip for today. We'll go to third question. There's a reason why I'm skipping it. When we come to second question after question number 4, I'll tell you why I skipped. Otherwise, it will create more confusion today. MV Hinchep arrives in seawater, dry dock, drawing 3.6 meters forward and 4.6 meters aft. kg FSM given. Find the virtual GM when the level of the water has fallen 1 meter after the stern has taken to the blocks. That means, what do we have to find? We have to find virtual GM. This is how we are thinking. I'm not solving the question, I'm thinking. For virtual GM, what do I need? P. When do I need the P? When the level falls 1 meter after the stern has taken to the blocks. Am I right, guys? Correct. Does everybody agree? Now
Yes, sir.
tell me, at what depth, look at the question, at what depth will stern make contact with the block? First contact.
6 meters.
5 meters.
6 meters.
6 meters, sir. First contact.
Question सुन ले मेरे भाई.
6 meters, sir. 6 meters.
Okay. The stern will make first contact at a depth of 6 meters. Does he want virtual GM though? Then no. He says after it has made first contact, level falls by another 1 meter. So what will be the depth at which he wants the virtual GM?
5
meters.
So that means what is the question? It is the language of the question which is going in circles. Actually, he wants virtual GM when at depth of 5 meters. That's the question. Am I right?
Right, sir.
But इस क्वेश्चन में 6 मीटर पे बैठ गया क्या सर वो? मतलब did she touch the blocks at 6 meters, sir?
I don't know. As per you, at what depth will she touch the blocks? Tell me. At what depth will the vessel touch the block? Tell me here.
6
What is
meters.
your-
6 meters because after the stern has
So then
taken-
what is your question? If you're
नहीं सर वो अपना क्वेश्चन ठीक है सर.
then what is your question? Guys,
सर वो
she
आपसे
will.
पूछ के डाउट दे रहा था सर.
So because you get 2 questions back at you, no? Then only there'll be doubt.
Yes. Yes.
Okay. Okay, guys. Now tell one more thing. Here is the important thing. At 6 meters, here are the blocks. These are the blocks. Okay. At 6 meters, the vessel is like this now. Just making contact here, and rest everything is clear. What is the depth now? 6 meters aft. Forward depth is also 6 meters. Draft is of course less. Now, guys, tell me one thing. Right now, how much is the depth? 6 meters. What is the draft aft?
6 meters.
6 meters.
Very good. Now, if I bring the depth to 5.5 meters, or 5 meters for that matter, let us say now I bring the depth. Yes, so please have one statement, repeat at least twice to yourself calmly. That at the point of contact, wherever it is, whether aft, forward, wherever, at the point of contact, once the contact is made, contact with what? With the blocks. Once the contact is made, the depth and draft change together. They remain the same. Like after seeing, once the contact was made, when you had a UKC of 2 meters, then the depth may have been 8 meters, but draft was 6 meters. They were not equal. Then UKC became depth became 7 meters, UKC is 1 meter, depth is 7 meters, draft is 6 meters aft. But when depth becomes 6 meters, draft becomes 6 meters, vessel makes light contact. But after the contact is made, now when the depth falls by another 1 meter, you do not know what will be the depth draft forward, because forward draft will change. Because when you discharge something from stern, now you'll understand why I was saying, let's take this method. Now somebody will feel that forward draft should also change by 1 meter. Forward draft will not change by 1 meter. Why? Because if you discharge something from here, forward draft will have two components. One is the mean rise, other is the TF component of trim cost. Correct, beta? Am I right? Is that clear? Correct? So the forward draft is not going to reduce by 1 meter. So don't think that forward draft will become 2.6. No, forward draft will be suffering or will be experiencing mean rise because of virtual discharge, as well as effect of trim caused at the forward end. So the only draft you can say with certainty is the draft at the point of contact. And I'll be using this statement very often. So please make sure you repeat to yourself, draft at the point of contact after the contact is made is equal to the depth, or the depth is equal to the draft, or draft is equal to the depth, is one and the same thing. So that means the question wants me to calculate virtual GM. You can say at depth of 5 meters or draft aft of 5 meters, whatever you want to say. Am I right, guys? Yes or no?
Yes, sir.
Okay. So first we have just, in this discussion, we just try to understand the question. We are not solving it. We just understood the question, what the question is all about. And second thing, we know, if he is asking us to calculate virtual GM, I need to get P. When? When the draft aft is 5 meters or the depth is 5 meters, whichever way you want to say. Okay. Before I explain you further, okay, now let's see this. Do you understand all this? I have already explained this. Stern takes to the blocks when the depth of the water above the blocks will be 6 meters. Does everybody agree? Yes or no?
Yes, sir.
Thereafter, this is the statement I'm saying. The draft aft, why aft? Because the stern has made contact. Thereafter, the draft aft and the depth of the water shall remain same throughout. Okay. Thus, when the level of the water falls by 1 meter after the stern has taken to the blocks, that is, the depth of the water becomes 5 meters, draft aft will also become 5 meters. Does everybody agree, or any questions on these 3 pointers, guys? You don't have to write this in the solution, guys. You have to talk to yourself and figure it out. That's all. It's only for self-questioning and moving further to find the way out. Okay, this is not to be put down in the answer sheet. There's no need. However, draft forward will depend on whether the vessel is within the critical period or outside it. Why? Because once outside it, the bow also touches, then the draft there also will be equal to the depth. But as long as the contact is not made, then you'll have to calculate it. Now there can be two questions here. When the level becomes 5 meters, can you, looking at the question, guys, and just look it with open mind and tell me with some logic. Looking at this scenario described, when the level becomes 5 meters, one is the vessel has the critical period begin at this level? Yes or no? When did the critical period begin? At what depth did the critical period begin?
6 meters.
Just after 6 meters. Very good. 6 meters depth, the critical period began. Very good. Now, when the depth becomes 5 meters, can you tell me, by looking at the question, whether the ship is within the critical period or has gone outside it? That means she is sitting completely. Looking at the question.
Within, sir, within.
Within, because forward draft is 3.6.
No, that's a wrong answer. She may be within the critical period. Logic is wrong. I just told you forward draft will change because if P turns is virtually discharged, then there will be changes at the forward draft because of mean rise and TF component of the trim cost. Yes or no, beta?
Yes,
Am I right?
Right, sir.
Forward draft is not going to remain 3.6.
Trim is
Understood.
2.4, so I think 1 meter is just.
There is
falling.
nothing like I think. There is something either there is something. There's nothing like think. Otherwise, your ship will make you think nicely.
Then we need to find out if the vessel is within critical period or outside it, sir.
So my question was simple. Looking at the scenario described, can you make out whether the vessel is within the critical period or outside it? Outside means gone past. Is it within the critical period or outside it?
We cannot decide it like this.
We can't figure out like this. So whenever there is a problem like this, where you cannot figure out whether the ship is within the critical period or not, you will first have to resolve this ambiguity. You'll have to first work out something to figure out only this issue, whether is she within the critical period or outside the critical period. Once you resolve this ambiguity, then the question will be further solved. Am I clear, beta? Have you understood the
Yes,
problem and the need
Yes.
to resolve it first? Okay. Okay. If the vessel is sitting on the blocks overall, that is outside the critical period, then the draft forward will also be equal to the depth because contact is made. But if the vessel is not outside the critical period, that means she is within the critical period, then the draft forward will need calculations. You can't say 3.6 or 2.6. No, that is wrong. And cannot be inferred qualitatively through discussion. Like we inferred the draft aft will be 5 meters. We can't do such discussion and say this will be the draft forward. Therefore, in such cases, it is important to establish whether the vessel is within or outside the critical period. So this is my first problem statement before I solve the question. Any questions on what is on display? If you have not understood anything, let me know. So in every question, you should figure, okay, first question, there was no doubt. He said, calculate the virtual GM at critical instant. So there was no doubt. You were not sure which instant he wants you to calculate, correct, beta? Right?
Right, sir.
In the first question, was there any doubt in our mind? No. He said, calculate it at critical instant. So matter was put to rest by the question. In this question, he says, calculate the virtual GM when the depth is 5 meters. So he's given me the depth. Okay, I can calculate the draft aft also 5 meters, but I do not know whether the ship is sitting completely or not sitting completely. Am I clear, beta? Am I clear?
Yes, sir.
So guys, when such a problem exists, don't make assumptions, because if you toss a coin, A, you have missed a step. 2, you have already taken a 50% chance. You may be right, you may be wrong. Okay. So first we'll resolve that. To that, I'll help you out. Please calculate the height draft now. Calculate the height draft of the ship on entry.
4.777, sir.
4.777. Is it right, guys? Please calculate.
Yes, sir.
Okay, very good. Very good. Now, we have to calculate first the upthrust at critical period, critical instant. At critical instant, we'll calculate the upthrust. And if you see the first question, what did we need? We require. Now I'm telling you how to think, what to interpolate. We needed displacement, we needed LCF, and we needed MCTC. 4 things we needed. In this question, I'm telling you to add one more TPC. Okay, so those 3 things, because we are going to calculate the P at critical instant first to resolve the ambiguity. So those 3 things and additionally TPC, please interpolate these for this draft of 4.777. So W, MCTC, LCF reason I have given you. TPC is an additional thing you will understand when we use it you'll understand why TPC was interpolated. For 4.777, please interpolate these particulars. And once you get them and match them, and if I'm proceeding, you can stop me if you're still in the interpolation process. Don't lag behind, because if you lag behind, you'll miss out on what I'm saying. Is that okay? Somebody's still doing.
Yes, sir, it's done.
And anybody? I'll take another 10 minutes, guys. Please bear with me. So don't worry. I'll take just 10 more minutes. Is it done, guys?
Yes, sir. Good to go, sir.
Okay. Now, what will we do? How will we resolve the ambiguity, guys? Please understand. We have to find out at draft. For this, what will we do? We will find out the draft aft at critical instant. This is what we are now going to find out. And this draft aft at critical instant, I can compare with this 5 meters draft aft, and I'll be able to figure out whether the vessel is within the critical period, yes or no. Right, guys? Am I right? Correct, Peter? Is that clear, guys?
Yes, sir.
So
Yes,
what
sir.
we are going to do is try and find the draft aft at critical instant, for which you have to find the P at critical instant. We have all calculated in the first question. Can you please calculate P at critical instant and give me the answer before I show it to you? That step, sorry, 543.3 ton. 43.3. Okay, anybody who's not able to get and recall? That is also reinforcing what we learned in the first question. We are getting P at critical instant. 543.3 tons, Sonar, are you getting it?
Calculate.
Karo,
Yes, sir, yes,
calculate. Did you get 543.3 or calculating it?
Okay, sir.
Okay, guys. Those who have got 543p, I'm asking a question. If I want to get the high draft at critical instant, if I want high draft at critical instant, can you think of it? How can I get it, guys?
Mean rise to initial high draft.
But we have an MV Hinship question. So
By subtracting displacement.
P upon T.
very good, very good. Because if P
W
tons is
minus
yes, if P tons is virtually discharged, then what can I do? I can just find out in seawater for W minus P the draft, and that will be the high draft at critical instant, yes or no? Correct?
Yes, sir.
Does everybody agree?
Yes.
If I find the high draft against W minus P from the hydrostatic particulars, will that be the high draft at critical instant, yes or no? Because I'm using P for critical instant. Am I right, guys? Class, speak up if you're not getting anything. Guys, I'm not getting to understand whether you're getting it or not getting it. Please let me know, because I can clear. Okay, so then give me the draft. Get me the height draft at critical instant. How many meters?
4.529 meters.
4.549 meters. Can somebody confirm? I'll show on the next slide. I have everything. I'm just trying to explain it to you here.
29, sir. 29.
29. Okay. Okay. 4.529 meters. Is it right, guys? Is he right, guys? Please confirm. Bolo bhai logo, please speak up so that I know whether you are getting it or not. Otherwise, the entire session will go down the drain, beta. You are telling me that height draft at critical instant is 4.529. Does everybody agree, or anybody has any question on this statement? Tell me, guys.
Agreed, sir.
Agreed? Okay. Tell me, guys, what is the if somebody is still doing something, you can stop me, guys. You can ask me to wait. I'll be happy to wait. So don't say that I was doing something else. How much will be the trim at critical instant, guys? Tell me.
Trim at critical instant is 0, sir.
Zero.
Sir.
So what will be the draft aft at critical instant?
4.529.
4.529. That means when will the vessel reach the critical instant? When the draft aft is 4.529. Am I right?
Yes, sir.
The vessel will reach critical instant when the draft aft is 4.529. Am I right, guys?
Yes, sir.
Correct? And
Yes,
what is
sir.
the draft? What is the draft aft for which we have to solve the question?
5 meter.
5 meters. So do you think at draft aft of 5 meters or depth of 5 meters, now tell me, compare this 5 meters and 4.529 and tell me now, does this tell you whether the ship is within the critical period or outside? What is your inference now?
Within, sir.
Within the critical
Within the critical period. So whatever we have done until now is not part, it is going to be part of your solution, but it will not give you the answer. It is only telling you whether it is within the critical period or outside it. Let me show the working then. At critical instant, we find P 543.3 tons. For this, we find the height draft. This is the height draft at critical instant. As the vessel is on even keel at critical instant, draft aft at critical instant is equal to height draft at critical instant is equal to 4.529 meters. And lastly, as the draft aft, after the fall of water level by 1 meter, after taking the stern taking to the blocks is 5 meters, which is greater than the draft aft at critical instant, the vessel is within the critical period. So whatever is on this page is only to figure out this part, whether she is within the critical period or outside it. Any questions, guys? Okay. Since she is within the critical period, we do not know the draft forward. Had she sat on the blocks, we would have known the draft forward is also 5 meters, but now we can't say anything. So now we go to our trim concept. Let me just explain to you here. We have aft, we have forward. Guys, if the question is with you, let me just open on my phone also. What is the draft forward, initial draft forward and aft? I'll open my question, no problem. I'm opening it here. The draft forward was 3.6 meters initially when she entered the dock, and draft aft was 6 meters. When does he want us to calculate P? He wants us to calculate P when the draft aft is 5 meters. Am I right, guys? Correct? Correct? Yes or no?
Sir, diagram is wrong.
You're not able to see?
Forward and after
Okay, no, man. Let me write aft here. Let me write forward here. Is that okay now? That's okay.
Not yet, sir. 6 के बाद 5 आएगा.
तो 6 के बाद नीचे 5 आएगा सर.
Okay, fine. Sorry, my mistake. Is it okay now? Thanks for correcting. Okay, guys? Okay. Then we know the LCF of the ship. We already have calculated in our initial working. The table we had the LCF. So this is LCF. Now, guys, why has this? What has caused the draft? Answer the question. What has caused the draft to reduce from 6 meters to 5 meters aft? What has caused the draft to reduce?
Reduced underwater volume, sir.
No, it is the upthrust. It is the upthrust. And where is the upthrust acting right now when she is within the critical period? Where is the upthrust acting?
At the start.
So here is the upthrust acting. And how much is the upthrust? P. Okay. This P has caused the aft draft to reduce from 6 meters to 5 meters, right? Am I right, guys?
Yes, sir.
Yes, sir.
Correct, Peter? Yes or no?
Yes, sir.
Guys, have you done such a question in trim type A problems? If you how much tons should be discharged from after perpendicular so that the draft aft reduces from 6 to 5 meters? Don't you think it sounds a very familiar problem?
Yes, sir.
Yes, sir.
Plus,
Yes, sir.
the draft aft is reduced from 6 meters to 5 meters because of this virtual discharge. And now you understand why I want you to follow this virtual discharge method better. This virtual discharge of P tons from the after perpendicular in our case has caused the aft draft to reduce from 6 meters to
5 meters.
5 meters. In trim type A problem, this line diagram is from trim type A problem, which we did in the last class. Which parameter can I make the equation into? Which is it that I know before and after? What is it that I know before and after?
Draft.
Okay, very good. So draft aft final 500 centimeters is equal to initial draft aft 600 centimeters minus mean rise. Guys, trim change because of P will be by head or stern. Tell me, TA will be minus or plus? Look at the line diagram. Minus TA. And when you transpose them from one side to another, it basically becomes 100 is equal to P upon TPC plus TA. Am I right, Vita? Yes or no? Correct?
Yes, sir.
Now, what is TA equal to? What is the formula for TA, guys?
Trim cost into LCF upon LBP, sir.
TA trim cost into LCF or AF upon MCTC. Right, very good. Look at the line diagram. What is the trim cost? Look at the line diagram. What is trim cost?
Sir, trim cost. Yeah, that's a P into LCF upon
E into LCF upon MCTC.
Trimming moment.
This is L. Okay. Into this LCF upon L, right, beta? This is trim cost, guys. Yes or no?
Yes,
This
sir.
is what we learned here in the last class. Yeah, am I? Look at the line diagram.
Yes, sir.
Yes, sir.
Correct? And this is equal to 100. And what did you do against 4.777 high draft? You have a LCF, you have MCTC, you have length. It's 143.16 for MV Hinship. You know everything but for P. And this will give you P at depth of 5 meters. Am I right? Yes or no, beta? Yes or no?
Yes, sir.
And
What
between
is
the
it based on?
P by
Trim type
TPC
A?
is missing.
Sir, P by
Sorry, beta?
DPC is missing.
Where? Okay, plus P by TPC. So, okay, plus P by TPC. Okay, fine. Can we find P at depth of 5 meters? Yes or no?
Yes.
Yes, sir.
Guys,
Yes, sir.
anything new? Anything new? If you have made a line diagram, don't you think it converts into what we learned in the last class? Yes or no?
Yes, sir. Yes.
Yes, yes.
And that is why I'm saying you need to be very comfortable with trim type A problems to have comfort with dry docking and grounding. Had we not spent that session yet that day, today all of us would have been fighting to understand it. And when you abruptly start explaining something without the beginning foundation, then there is a problem. And this is what it is. Let me show you what is there in my working. And if you have any, so my working will start from here. Change in draft aft is result of your so okay, let me show it to you then. Okay. Thus, when the depth of the water is 5 meters, what happens from the, I have not made the line diagram, I just made in hand and showed you. The change in draft aft is 100 centimeters because it changes from 6 to 5 meters. This is only an explanation of it. As the vessel is within the critical period, the change in draft aft is due to the upthrust acting at the stern and is resultant of mean rise because of P and the TA component of the trim cost, which means change in draft aft 100 centimeters is equal to mean rise plus TA is equal to this. Can you now calculate P, guys?
$369.44.
Okay, 369.5 tons, good. If anybody has not understood anything from this question, please let me know. Even if I have to go back or explain something some other way, I'll do that. But you guys should not just say, I'll see it in the evening, maybe I'll understand. Don't leave it for yourself to waste time on it. If you have a problem, let me know. So guys, when the depth of the water comes down to 5 meter, the upthrust will be acting at a single point, that is the stern, and the value of the upthrust will be 369.5 tons. Am I right? Am I right?
Yes, sir. Right.
Class, follow me. And once you have the P, you can get the virtual GM. I don't think I have to explain you that now. The last step you did in the question number 1. What did you do there? After P, what do we need to do, guys? A revision, quick revision. Tell me. What do I do now? Very good, very good. First get the Km for W minus P. First get the Km for W minus P. Very good. Please get the Km for W minus P and the Km would be so much. You have the displacement, you interpolated displacement. From there, subtract 369.5. Whatever you get the Km, you'll get it 9.189 meters. And once you get this, can you please close it out? If you want kg and other things, you can see on the phone. The questions are already shared in the group. So can you now get the virtual GM before I show it to you, beta? Please get the virtual GM. If you have a doubt, then I'll show you the working. You can correct yourself. The answer for the virtual GM is given in the question. So question number 3, it is 0.642. 0.642 is the answer. See if you're getting it or not. Are you getting 0.642? Please confirm.
Yes, sir, got 0.642.
Yes. Here is the working for the GM. And that is the answer to question number 3.642 meters is the answer. But in this question, since the stage of the dry docking was not clear from the question, we first had to determine the stage, whether she is within the critical period or outside it. And that stage was to be first evaluated. We did the evaluation, and then based on the outcome of that, we took our decided on our course of action to get P. And once we get P, this table will be a standard table to get the GM, virtual GM in every question after getting P. Guys, what you need to do is revisit the concepts, revisit question number 1 and 3. Revisit does not mean that you just learn a number 3 question that I'll do like this. Please talk to yourself, reason it out. If you're not able to reason out something, let's discuss it in the next class at the beginning tomorrow itself. Tomorrow morning we are meeting again. So please spend some time tonight, an hour and a half. And a small thing you have to do before we meet tomorrow, you have to read this question number 4. Guys, read this question and tell me, is the stage of dry docking clear from this question? Do you know the stage of dry docking from this question, yes or no? When I say the stage of dry docking, is she within the critical period or outside? That is what I mean by the stage of dry docking. Is it clear, yes or no?
That we will find out, sir.
No. Is from the question, is it clear or not? My question is, from the question, is it clear or not?
No.
No. So that means first you will have to evaluate the stage. Like question number 3.
How we had already done. मतलब सर हमें ड्राफ्ट आप निकालना पड़ेगा क्रिटिकल इंस्टेंट पे, तब हमें पता चलेगा ना.
जो भी है फर्स्ट पॉइंट ऑफ कांटेक्ट तक करना है, एंड वो आफ्ट है, ठीक है. सो लेट्स नॉट ऑलवेज से ब्लाइंडली ड्राफ्ट आफ्ट निकालना है. ड्राफ्ट आफ्ट इसलिए बिकॉज दैट इज द फर्स्ट पॉइंट ऑफ कांटेक्ट, राइट? ओके. Secondly, please, so your expectations for tonight is review of the theory that we have done, question number 1, question number 3, and question number 4 only up to finding the stage, up to stage determination. No further. Whether she is within the critical period or outside, so that tomorrow morning you can check those values with me. And when you do on your own, guys, what will happen when you start evaluating the stage for this? You may have some doubts. You will be forced to refer to question 3, reinforce it. Okay. When you keep looking at the screen, you'll never learn it. So what is that you have to do is review the concepts, explanation for critical period, explanation for critical instant, question number 1, question number 3, and question number 4, you only have to determine what stage of dry docking is the vessel in. Is that clear, beta? Clear, guys?
Yes, sir, clear.
Okay. Do this. Yes. Yeah, do only this much. And let me just tell you, in question number 4, you will find the vessel is outside the critical period. And then tomorrow we'll see how do we find P in this case. And when you see that approach in this question will be different, then you'll also realize why it was important to determine whether the ship is within the critical period or outside it. So guys, tomorrow we have a class at 9:30, am I right?
Right, sir, right.
Yes,
So we
sir.
are meeting we are meeting at 9:30 tomorrow. So put in an hour and a half today. Make sure you put up revisit these concepts, and tomorrow We'll be much more comfortable. So whatever doubts you have coming to your mind today, by end of the class tomorrow, they'll automatically be taken care of. So don't try to be too adventurous trying to solve questions. Just revise what has been done, let the foundation be in place, and then by end of the day tomorrow, all of you would be comfortable with it. Okay, beta?
Okay, sir.
Okay, guys, then I'll take your leave. See you tomorrow at 9:30, okay?